Hello everyone, welcome to the new course Mastering QGIS, a comprehensive guide to the GIS fundamentals, data management and visualization. It's me Hemraj Pandey to teach this course. Before we start this session, if you haven't subscribed to the GeoDev channel, please subscribe the YouTube channel and press on the bell icon for the real-time notification. Now let's get started the session. This is the overall table of content we are going to cover in this session. I will start from the introduction to GIS and QGIS and end the session with the database connection. During this session, we will look the geoprocessing tools, digitization, georeferencing, digital elevation model, and I will teach you how to design the map. And also, I will introduce about the plugins, and we will also convert our QGIS designed map to the web map using this QGIS to web plugin. Also, I will teach you how to download the QuickOSM data using the QuickOSM plugin. So let me start from the introduction part. What is the GIS? GIS stands for Geographic Information System. It is a technology that combines maps and data to capture, store, manipulate, analyze, and present spatial information. There are the number of the software available in the market. Among them, QGIS, the open source, powerful software that is available under the open source license. Anyone can download the QGIS and easily do the GIS operations. It has interactive, user-friendly interface and well-arranged tools. Now let me see this interface of the QGIS. This is the interface of QGIS. Here the number 1 is the layer list, number 2 is toolbar, number 3 is map canvas, 4 is status bar, 5 is sidebar, 6 is locate bar. Now we will we will see this interface on the QGIS software. So for this you have to download the QGIS software first. Please download QGIS software. Go to the Chrome or any other browser and search QGIS download. Also you can go through the description as we have provided the link, and when you search the QGIS download, you will get this search result, and click on the first search result, and when you click on the download QGIS, it go enough to download. Here you can see it is around 1.1 GB. So as I have already installed the QGIS, I am not going to download this. As I am using the Windows, so I downloaded the Windows version. So if you have a Linux or Mac, you can download the Linux and map associated QGIS. For this you have to refer to the documentation part. You can easily download on this operating system also. Now we are going to open. To open, you have to search QGIS desktop. Here you can see, and when you click on QGIS desktop, it is going to open. It is loading. Now if you are going to add the shapefile as a layer, one thing you have to know that along with shapefile you must have a shapefile index .dbf file to load the shapefile on the GIS software. As shapefile contain the geometric data including point line polygons, this is not enough to load in the QGIS or any other GIS software. So you should have shapefile index file .dbf file. Index file that stores the index information, but dbf file stores all the attribute data associated with special feature. Shapefile is a vector data We will later discuss about the vector and the raster data in the next presentation slide. Also, these are also files which are usually available with the shape files. .prg file, .ssp, .xml file. PRG file stores the coordinate system information, while .sp.xml file stores the shape file metadata about the shape file. Metadata means it is the data of data. That is data source, author, description, or the relevant details. Now we are going to load the data in the QGIS. For this, you have to go to the layer menu, and here you can see the number of the options. Now go to the add layer section and click on add vector data layer, and here you can see the interface looks like this. You have to go to the right three dot section to browse the data, and as I have the stored data in the GeoDev folder, you can download this data from the description link. Now I'm going to add this shape file. For this, simply click on this and open, and you can see the detail. It's path, and click on the add to add the data. Now we are going to work with this layer. Here you can see here are some options to control this layer. You can add group and many more. You can explore by hovering over the icons. And here when you click on the when you right click on this, you can see zoom to layer. Zoom to layer means if your layer goes outside and you cannot find the layer where exactly it is located. In this condition, you can click on the right, click on it and zoom to layer to zoom to a specific zoom level. Also, you can zoom out, zoom in by simply mouse, but also you can zoom out, zoom in by these two icons also. And this is the pan map. Pan map means you can pan the map and look throughout this drawing map canvas, map views. Now I'm going to zoom to layer. Here also number of options. You can show label to label the polygon. You can also go to the open attribute table to see the data. Also, you have the toggle editing option, filter, layer CRS options. Now we are going to the property section, and in property section you can see this is information about this layer. This is the source, and there is the coordinate reference system. Also you can change the coordinate reference system from here. Also, if you cannot find by sliding here, you can go to this icon, this icon here. It is the icon here, a high level here. You can click on this to source the coordinate. Okay, now you can simply source like this WGS. You can see the number of result here, and you can click on any of these to change your coordinate system. Now I'm going to change it to projected coordinate system, as Nepal lies in the UTM zone 44N. So I set it to UTM zone 44N and apply it. As soon as you apply, the layer disappeared. It means for this again you have to go to the zoom to layer and zoom to the specific zoom level. Now we are going to working with the symbology. For this you have to click on the symbology. Here you can change the color of the overall map. Here you can see the map color changed. Also you can give the different color for different province. As we have the total of 1 2 3 4 5 6 7 province, you can click on the simple fill, and here you can you can go to the click on this icon. See, here you can click on this sliding menu and click on categorize, and then you can give the random color. Here you can click any of these, and when you click this, no change to any. So for this you have to click on the classify. Before classified you have to give the value to categorize the color. As I'm going to categorize according to PR name, so click on the PR name, and when you click on the classify, it classify the color. As this is the extra color which is assigned by the software, because usually if there is there will be the other polygon which have not categorized. In this condition it assigned this value, so I'm not interested to add this value, so I'm going to minus it, delete this, and when you apply and give the OK, it gives the different color for the different province. In this way you can change the symbols according to. Let's start the data type in GIS. In GIS, there are the data types: vector, raster, triangular, irregular, network. In this course, we only focus on the vector and the raster data. Here you can see in this figure, this raster data is made from the small value pixels, small grids. And in vector data, this vector data is made by joining the mathematical coordinates. So let's clear from this slide. Here raster data is pixel based, while vector data is mathematical curves and lines. Raster data is best for photographs, aerial images, satellite images, while vector data are best for logos, type, and geometric design. Relatively, raster data has a large file size as compared to the vector data, and spatial accuracy of raster data depends on resolution of the grid set, while vector data can represent precise spatial location and shapes. If you are a designer, you may know the Adobe Photoshop is the raster-based software, while Illustrator is vector-based software. So we usually uses the Illustrator for the designing the flex, logos, and other CAD design. But Photoshop is usually used for the editing the photographs, erasing the background of photographs. So you can clear from these two example also. Now after this vector raster data, we are going to study the geoprocessing and geoprocessing basic tools. What is the geoprocessing? Geoprocessing refers to a set of operations and techniques used to analyze, manipulate, and transform geographic data within a geographic information system (GIS). It involves a series of computational and analytical operations performed on the spatial data to extract information, create new datasets, and derive meaningful insights. Geoprocessing encompasses a wide range of tasks, including spatial analysis, data conversion, data management, and more. Let's clear from these geoprocessing methods. In this course, we only do the buffer and clipping in the software, but for the basic understanding, we also added this union and intersection slides. Now, what is the buffer? Buffer means increase the dimension of the feature. Let's clear from the real world example. if you are constructing the building and want to plan the boundary of the building, to plan the boundary of the building, you can simply import the building polygon in the QGIS, and then you can buffer in any give him the radius, buffer radius. Let's say if you give the 10 meter buffer radius, you will get the 10-meter boundary of the building. Similarly, in clipping, you can give when this is the input feature and this is a clipping feature. By clipping this feature, you will get the all the information within this feature extent. Here we will clip in QGIS later. In union, you can understand from its name also. Union means its intersection plus remaining. In intersection, you will only get the intersection part of two features. So these are the some basic concepts of the geoprocessing tool. Now we are going to clip the feature. For this, you have to add the two layers, input layer and clipping layer. For this, we have to simply add the layer. For this, we have to add the layer. Here you can I have added the data in the Geoprocessing, and here you can see this folder. You can download this data from the description link. I am adding the data. Input data is road shape file. It is the shape file of road network within the Nepal. Also, I am gonna to add the clipping layer. For this, again we have to repeat the step. Where is this? Here you can see this is the clipping feature area. It also added here. As you can I cannot see the this layer. It is due to the different coordinate system on these two features. For this, I gonna to fix this issue. For this, click on the properties and click on the source and click on it is by default UTM zone 44N, so I'm not gonna to change this, and I'm gonna to change the yes, this is different from the Sudur province coordinates, so I'm going to change it to UTM zone 44N again. For this, apply. Okay, now you can see, sorry, you can see the two different feature overlapping. So I'm going to extract the road network within this Sudur polygon only. This Sudur polygon only. For this, we have to do the clipping operation. I have to give the input feature as road network and clipping feature as Sudur. For this, you have to go to the vector menu. Here you can click on vector menu and click on the geoprocessing tools. If you cannot see the processing tool on this, you can simply click on the plugins and click on the manage and install plugins and search for processing plugin. Here you can see, if you cannot see the geoprocessing tools menu, you can go to the plugin, click on manage and install plugins, and you can install by searching here. Okay, as I have already installed this processing plugin, we do not need to install it. Now click on vector, click on geoprocessing, hover on the geoprocessing tool, you can see the buffer clip. I'm going to clip, and I'm going to input layer as road network, and overlay layer or clipping layer as Sudurpasim. Now you have to click on the run. It is going to, I think it clipped. Okay, now close, and when you of these two layer, you can see only the road network within the Sudurpasim province is visible now. Here you can see. I'm gonna to change the symbology so it's easy to visualize. For this, I'm gonna to click on grayscale, gray 1 fill, apply. Okay, now you can see it clipped the road network within Sudurpasim province only. In this way, you can do the any operation according to your requirements. It is just example. And now we are going to buffer the layer. For this, you have to add the layer which you want to buffer. I'm going to add the vector layer, browse from here, and go to the georeferencing buffer. Yeah, I'm going to buffer the hospital buildings. Here I have 3 hospitals. I'm going to buffer it. For this, you have to go to the vector geoprocessing buffer. Now it is showing in the degree. It is in the geographic coordinate system. It is not projected coordinate system. Now let's give the 0.001 degree and click on run. Now you can see it buffer. In this way, you can buffer the any of the point line polygon features easily, and you can also buffer by changing its coordinate system in projected coordinate system. Then you can buffer in the meter unit. We are going to look digitization in QGIS. Before we start to digitize in the QGIS software, we have to know some basic concept. What is digitization? Digitization is GIS refers to the process of converting analog or hard copy maps, images, or weather spatial data into digital format, making them compatible and usable within a geographic information system. This conversion allows for efficient storage, analysis, manipulation, and visualization of the spatial data. This is the concept of the digitization. Now let's work with digitization. For this, you have to add the layer which is to be digitized. Go to the add raster, and inside digitization folder I have provided this cascadistic JPG file. You can add here. After adding, you have to create the shape file. Here is the new shape file layer. Click on it and give the proper name. And you have to give the geometric type. As this is the polygon, I am going to add the polygon. If you are going to digitize point, multi-point, line string, you can go through these options also. Here ID is already added, but I am going to add the name in attribute also. This is the attribute section. You can give the attribute field, and later when you digitize compile it, you can give the name of to these fields. After giving the name, you have to click on add to field and OK it. I think this is saying the layer already exists. Are you want to override the existing layer? I think this for this I am going to cascadistic DIST. Okay. Okay. Now here you can see cascadistic shape file has been created. Now for the digitization, if this toggle iterating button is used. If you have not see this on your QGIS, you can go here and right click and go here and activate this digitization tool. Now I am going to digitize. For this you have to simply click on this cascade stick and go to this toggle editing option. After clicking, click here add polygon feature. Now you can process your digitization operation. Now here you can see it is going to digitize. As this is just a demo, you can maintain accuracy on your digitized layer by zoom in specific zoom level to make it more accurate. I'm just giving the demo, so it is not mandatory to make it accurate. Now I have almost done it. Here it has been done. After editing, you can click on right click and give the ID. The ID is 1 and name is Cascade and OK it. Now here you can see when you untick it, and you can customize its symbology to visualize easily. Okay, this is the shape file. Okay, not shape file, it's a digitized layer of the cascade stick. You can go to the attribute table here, open attribute table and see this attribute information also. Now let's do georeferencing. For this, if you are using the 3.28 version, you can find the georeferencing inside this layer menu. And if you are using the version others than this 3.28, you can find inside this raster menu. But I am using 3.28 version, so my georeferencing panel is here. Now before going to georeferencing, you have to on this quick map surfaces OSM layer. As I have already introduced about this map services, quick map services before. Also I am going to repeat this again. You can download this quick map services from the plugin. You have to search here quick map services and click here and install here. As I have loaded this layer, now I am going to do the georeferencing. For this, you have to click on the georeferencing. As soon as you click, the new layer panel is open, and here you can add the open raster. And as I have given this file inside this georeferencing folder. You have to load this on this georeferencing tab. Now what you have to do is you have to click on any of the feature body. Now I am going to add the coordinate here. Here you can give the manually, you can write the manually the coordinate, but I'm going to add it from the map canvas. Click on here. Now I'm going to tick here. When you click here, this x and y field is automatically filled. Now click on the OK, and now I'm going to give this here from map canvas. We have to find this in this map canvas and click here. As I'm going to only giving the demonstration, I'm not going to make it more accurately, but you have to do it more accurately. Okay, now fill here also again. Click here. Okay, from map canvas, somewhere here. Okay, you have to give the at least 5-6 coordinate to make it accurate. I'm going to give this location coordinate. I think this is our main target. Click on here. Okay, now I have successfully referenced give the 5 coordinate points. Now I am going to save it. For this you have to go to the setting and click on transformation setting. As this is the WGS84, I am going to switch to the WGS84 EPSZ4326 and click on OK. As soon as you click, the setting has been saved, and click on start georeferencing. Here you can see georeference successful. Raster was successfully georeferenced. When you minimize it and go here, you can see it exactly fit on this OSM base layer. Okay, when you untick it, you can see this is the map of the Nepal. When you activate this, you can see it exactly fit on this real world map, real world base layer. OSM is base layer. In this way you can do the georeferencing. It is quite easy. You have to follow the some step. Now digital elevation model, DEM. What is digital elevation model? Digital elevation model, DEM, is a digital representation of the Earth's surface, capturing the elevation or terrain data of a specific area. It is a grid of the elevation values that represents the height or depth of the terrain at regular intervals, typically measured in the meters or feet. DEM data is derived from various sources, including aerial LiDAR, surveys, satellite imagery, or topographic maps. The elevation values in a DEM can be used to create visualizations, perform terrain analysis, generate contour line, and model hydrological process. Now we are going to download the DEM data. for your map canvas extend. For this you have to load the OSM standard base layer. For this you have to click on the quick map services, and here you can see OSM standard. If you have not the quick map services, you can simply search here and download this. Now to download the DEM data, you have to go to the manage in the install plugins section and search srtm downloaders, and simply tick here and click on install plugin. Now it has been installed. You can see it, you can access it from the plugins srtm download. Now we are going to download it. For this you have to set the canvas extend. Click on the set canvas extend, and now click on the download button. After clicking the download button, it's wanted to access your username and password. For this, you have, if you have not the account, you have to go to this link and create the account. I'm going to create the account here. Now I have successfully registered the account, and now I'm going to log in. It was take 1 to 2 minutes to register the account. And click on OK. I think click on download. Okay, now you can see this is the .sgt dam which we have downloaded. Now in this way you can download the DEM from SRTM download plugins, and you can do many more using this dam. You can do the hillside analysis, you can generate contour, so on. Thank you. Now we are going to design the map. For this you have to add the layer. For this I am going to add the vector layer. We browse from this icon, and as I have provided this map design, the content inside map design, you can go through this and click first you have to add this shape file. Okay, add, then again go to the layer and add layer and go to the add delimited text layer. Delimited text layer, we are going to add the CSV file format. Here we have the CSV file. Click on this. We are going to design the orthoquick dot density map. Here you can see it automatically filled. If you have the invalid geometry problem, you can click here and assign the coordinate system. Now I have no any. As you can see, these two maps are defined at different coordinate systems. The position of the orthoquick data is somewhere outside this Herman's NPL new WGS. So I think we have to change the coordinate system. For this you have to go to the properties section and go to here. Here you can see it is different from the previous orthoquick data. Here you can see now it is exactly overlay on this shape file. Now we are going to change the symbology. So I for best representation, I'm going to click on gray one fill and apply this. Okay. Now from the project, click on new print layout and name this layout. I'm going to name Nepal or the. Okay. Here you can see this new layout is visible now. Here two windows are open. You can switch by simply hovering on this icon. Now you can set up your print layout from here. Here you can change to any of the orientation and letter format. I'm going to do it A4 as I am going to design a landscape. You can switch into portrait mode also. I'm not going to add portrait, so I'm by default there is a landscape. Now first of all, you have to add the neat line. To add the neat line, you have to click on this shape icon. When you click on, there will be the three options. I'm going to click on add rectangle and going to draw the rectangle by making like neat line. As it is neat line, as it is rectangle, there is a no hollow in the middle. This is the border stroke, and inside it here is a white color. So for this we have to make it hollow. For this you have to go to the properties section and click on style drop down and click on configure symbol and click on simple fill, and here in fill style you have to click no bruise. Now the it it's it is hollow. Now I am going to add the map. You have to click on the zoom to layer first, and then you have to start the adding the map. For this you have to click on add map and drag it. Now here you can see map is added. You can give the title from this at level, and I'm going to add the title. For this you have to write here. Okay, here you can see this is the earthquake Nepal map, and you can change the font size from here and font also. I'm going to change it to 25. Now you can adjust this position. Here you can see here is the center option also. Now we can add the orientation. Here the north arrow option, you can click here and drag it. Here you can see this is the north arrow. Also you can add the scale from here. Click here and drag it first. Scale is also added. For legend we have to do some operation. For this you have to return to main page and go to the earthquake Nepal properties. And here you can see we are going to make the dot density map. For this you have to change this single symbol to the graduated, and you have to choose the value. I'm gonna to give the value here mag. We are going to give the color based on the magnitude. As you can see, when you close this and open the uh, CSV file, okay, you here map design earthquake Nepal. Here you can see here MEG section has the magnitude value. So we are going to give the make the map graduated symbol map based on the magnitude. For this you have to choose graduated value as MEG, and a color ramp you have to give any of color ramp. When you classify, it automatically classify according to magnitude value, and you can apply it and OK. Here you can see the color has been changed. Also, as this name is not a perfect name to represent the provincial map, we have to go to the properties section, and here you can go to the source section and change this name to province. OK, apply. When you change the made change on this main QGIS software, the it automatically changed on this page layout also. Here you can see color has been changed here also. Now we are going to add the legend. For this you have to click on the legend and drag it. Here you can see legend also added now. Okay, you can adjust the size like this. Now we are going to add the author or designer, who is the designer of this map. For this you can simply like adding the title. You can give design equal to your name. Okay, as I am going to you can change the font size from here. Okay, I'm not going to make it large because it is not important things we have to portray through the map. One thing you have to know when you design the map is you have to give the best color for representation, and you have to focus more which is important on the map rather than those things like designer, who is the author, like this. Now you can export this map by going on layout menu, and here you can see you can export as PDF also, you can export as image also. We are going to save it to desktop GeoDev, and here okay, save it. You can give the export resolution as by default it is 300 dpi dot per inch. I'm not going to change this and save it. Now it is going to save. Now you can see this inside here. Here, this is the map we have designed just before. It is looks like good. You can change and design your map according to your requirements. Thank you. Hello everyone. Now we are going to work with plugins in the QGIS. QGIS provides the number of plugins for specific tasks. In this session, we will only work on QGIS to web plugin and QuickOSM plugin. So for this, you have here plugin section. You can go to the manage and install plugins for installing and uninstalling the plugins. Now we are going to create the one web app from static QGIS map. For this you have to go to the all and you have to search QGIS to web. Here you can see. Click on here simply right and install plugin. Downloading data. It uses open layer leaflet web map. Now again you have to download the quick map services for the OSM base layer and other base layer. So for this you have to again install the another quick map services plugin. If you have not the coding background, you can simply convert the QGIS map to the web map. Now we are going to create one load the one layer and convert this into the web map. For this we are going to add the vector layer. Browse here. We are going to add this Herman's shapefile here. Open here. Okay, now it's loaded on the QGIS. Now you have to go to the web menu and click on quick map services and click on OSM stand or to load the this base layer. Now go to the web again and click on QGIS to web and create web map. Click on create web map. Now here you can see you can customize layers. You can give the visible pop-ups again. You can also change the appearance. You can also give the mass product CRS template. You can also highlight on hover layers or zoom level again. You can customize according to your requirements. It is simple. You can easily do this. You can export it to the folder. For this I am going to export it into the GeoDev export folder and click and select the folder. And when you click on export, it is going to export to the web map. Here it automatically open when it exported. Here you can see this is the web map. You can click on any of the feature and it pop up. Okay, I think we do have not sorry it now work. Okay, here now we are going to work with QuickOSM plugin to download the OSM data. For this you have to go to the plugins manage and installing section and you can simply search QuickOSM here. Click here and click on install plugin. It is going to install now. Now it has been installed. Now you can access it through going to the vector and here you can see QuickOSM and click on QuickOSM to download the data. Before going to download, I am going to add this OSM standard base layer. Here you can see OSM map services and click on OSM standard. If you have not see this quick map services, simply go to the manage and install plugin and again source. Again you can source the this name quick map services here. Quick map, this is quick map services, and click on install button here. Now I am going to add the uh, OSM standard first. After clicking it, I am going to zoom to the my location as I am in Pokhara region. So I am zooming here, and now you can go to the plugin, sorry, vector, and go to the QuickOSM and click on QuickOSM button. Here you can see this is the overall panel looks like when you click on the QuickOSM. Here is the map preset query OSM file parameters about. In about section you can explore it. Click on quick query and here you can download the data. You can give the key and value to download also. Not I am going to sort the I am going to download the secondary highway street. For this I am going to GRETS secondary. Here click on secondary, and when you click on run query, for this you have to select the region. Here in the left section it is in. I am going to download canvas extend. All the OSM with key highway secondary in the canvas or layer extend are going to be downloaded. This layer extend will be downloaded when you click on canvas extend, and when you click on the run query, it is going to download successfully. Query 2 layers has been loaded. Now here you can see it is loaded here. By clicking off, here you can see this. Now I am going to increase the line width so that it is look good. For this I am going to increase here. When you increase the width, you can see this secondary highway street. As I have selected the canvas extend, it only download the highway within this layer extend. In this way you can download the data from the OSM in a few seconds. It uses overpass API to download the data. You can see here in the documentation also. Now we are going to connect the database to the QGIS. In this video we'll also see how to connect the QGIS to the database and how we can load the file, shape file, JSON file from QGIS to the PostGIS. For this you have to download the PostgreSQL with PostGIS extension. Now you can see we have this previously added database. Now I'm going to create one new database. Let's name it demo, and here you can see extension. Click here, right click here and create, and click on extension and source PostGIS. Click on here and save. Now we have added the PostGIS extension here. Now go to the schemas and click on tables. There is no any table till now. This special reference system is due to the PostGIS extension. Now we are going to connect the QGIS to the this
PostgreSQL, PostGIS. Now here you can see there is a number of database. Now we have to right click on PostgreSQL and click on new connection. Here you can see we are going to give the name demo host, give the local host. Here I have port number 5433, database is demo, and you can check test connection here. Now you have to give the username postgres. Now you have to click OK. I think okay, you have to have a wrong username entered, so okay. Here you can see connection to the demo was successful. Now click on OK. Here you can see I have the demo uh, database and also public schema. Now we are going to add the file to this public schema. For this you have to click on database DB manager and click on PostGIS, and you can click on public. Okay, here you can see there are already exist these folders. Here also we can verify through here. Okay, we have already this special reference system, so here also you can see special reference system. Now you can click on here, right click on demo, you can click on here, simply select public and go to the import layer files, and here you can see three dot browse button. Click on here, and here you can see I have stored the files in these folders. Now I have one file, GeoJSON file, inside the import Geojson. Click on here, you can simply check the description box for these datasets. Click on hospital and open it, and when you click on OK, now import was successful. You can check through here also. Here you can see hospital has been successfully uh, uploaded to the PostGIS. You can also check here, go to the I think a demo and refresh it first. You have to refresh, and here you can see hospital, and click on here view data. You can see the our GeoJSON file. Here only we have the three features. You can click on geometry to see the data. By click on this feature, you can simply reveal the information also. Thank you. Thank you everyone for watching this course Mastering in QGIS. If you have any feedback, queries and questions, please write down on the comment section. And you can follow me in the LinkedIn account and can contact through the LinkedIn also. And if you have not subscribed to the GeoDev channel, please subscribe it and press on the bell icon for the real-time notification. Thank you.